Well, everybody. How's everybody doing? The local time is 1:46 p.m. on a Friday afternoon here, a very windy Friday afternoon. And we will begin our program on the San Juan Islands at the top of the hour. Less than 15 minutes from now. Thanks for joining us today. Our discussion today, 2 p.m. Pacific time here on the west coast of North America. You may not know where the San Juan Islands are if you're watching from a distant place, but we'll fill you in. And then if you come back on Sunday morning, 9 a.m. Pacific time, and we change our clocks here in the United States, so we fall back an hour, but I'll see you at 9 o'clock Sunday morning, going to the foothills of the Cascades, the western Cascade foothills. Are we functional? Garrett, the Dutch night owl. Great to see you. Hey, you know who I heard from this week by email yesterday? Norley. Norley emailed me from itchyboots.com. That was the thrill. But it's a thrill to see you too. Old Salty OSO, John says it's very good. California, David, yes, I'm seeing where you are. And if we're 5x5, etc. Greece, hello. Ontario, Canada. The Everglades. The Methow. Newport, Oregon. Port Orford, Oregon. Boise, Idaho. Edmonton, Canada. Darrington, Washington. Hello, Gary. The United Kingdom and Tennessee and Alberta. Nobody's telling us about our smoke detectors and the... our batteries in our smoke detectors. Hello, nobody. Daddy's here. Paul's from Burlington. Kingston Ferry. You're on the ferry right now? That's cool. David's in Edinburgh, Scotland. Jean's in Los Angeles. Stephen's in Portsmouth, UK, and still raining there. Squim, Washington. Anacortes. Sharon, your neighborhood today. Agassiz, British Columbia. Taro is from Finland. Stephen from Everett. Carol from Paris, Illinois. Frederick. Saskatoon. London. Hello, Jerry. Jody's from hello. Oh, she's just saying hello. Bavaria. Great to see you. I love the people from distant lands, especially Frankville, Nova Scotia. I love everybody, but I mean, it's always a thrill. Rotterdam. Chico, California, Happy Valley, Oregon. It's howling here. It's 30-mile-an-hour winds, and the cold front is pushing through, but kind of under the shed roof here and kind of protected. Oh, God. Hey, man, I got thank yous. Why am I screwing around with this? I can't keep up, as usual. And it's an embarrassment of riches. So Consuelo, thank you for, Consuelo in Seattle sent me a book that I didn't know about. Ned Brown from Bellingham, Washington. We're going to talk about Ned a fair amount today. She sent me this book a couple weeks ago, and I've used it quite a bit, Consuelo, for this lecture. So very helpful, very timely. Thank you for that. And speaking of books, Jim in Prineville, Oregon, Jim says, yeah, I found these at a book sale. Maybe you can use them, says Jim down in Prineville. And he says, be careful with this one. This is from the 1960s. What did you say? It was printed in 1966. It's trying to come apart. Geology, an Introduction to Principles of Physical and Historical Geology. Thank you, Jim. And a separate package from Jim, more books. Now I'm a clearinghouse. Patrick, this is for you, from Jim in Prineville. Thank you, Jim. But wait, there's more. Knock on the door early this morning. Huge box left outside the house. From Eric and Jay in Bakersfield, California. Yay. And inside of that huge box are 3 of these like freezer bag kind of things with zippers on them. Oh God, I don't have time for you. Bijou's here, I don't have time. Dear Nick, Jay and I have been watching your classes since March. We want to thank you for all the work you're putting into getting okay, very nice stuff, thank you. Jay and I thought, since Halloween is one of our favorite holidays, that we'd share a bit of it with you. You'll need to open the cases in order or it really won't make sense. We hope you enjoy the goodies. Even the ice is reusable. Eric and Jay from Bakersfield. So in freezer bag number 1, first you rip it open. Okay, hot dog buns. All right, they want to see you. Happy Halloween, happy Halloween, happy Halloween, happy Halloween, happy Halloween. Yeah, okay. Freezer bag number 2. So we got hot dog buns so far from Jay and Eric. Organic ketchup. And beef hot dogs on ice. And this says, what does this say? Then you pour the ketchup blood red. Okay, what do we got? Hot dog buns, hot dogs, and ketchup, blood red. Well, there's a third freezer bag. And then you pour a nice cold drink with the hot dog in the hot dog bun and the blood red ketchup and some spiced cider. Happy Halloween. Thank you, fellas. And then an hour ago, the doorbell rang again, or the knock on the door again. FedEx guy, Curtis from Yakima. He's like, hey, Nick on the rocks. How's my hair? He's like, yeah, I got a box for you. This box is from Scotty. That's the state of Wisconsin. From OH Danish Bakery. This episode of Nick from Home brought to you by OH Bakery, Danish Bakery in Racine, Wisconsin. You gotta love it. And there's only one little card. It says, a gift for you, happy Halloween from Dick. Dick, are you in Racine? Wherever you are, Dick, thank you. So, shall we look at what was delivered? It's a Day of the Dead layer cake. Very kind of you, Dick. Might have to freeze this one too, otherwise I'm going to eat the whole thing tonight. We don't need that. I'll have a slice, maybe with everybody at the end of this show. How about that? I got one more. I'm sorry, but so thank you to everybody. I got one more. And I've had this one a while. This is from a box. The box is from Mark in Tucson, Arizona. Hi, Nick. Thanks for your current exotic terrain seminar and also your past lectures. I'm a retired oil and gas geologist, and your videos scratched an itch for a busman's holiday without leaving my chair. Enclosed is a hand sample of one of Arizona's exotic terrains, 1.75 billion year old hematitic jasperoid banded iron formation collected on Mingus Mountain a few miles southwest of the town of Jerome, Arizona. This terrain, called the Yavapai, is a northeast trending series of island arcs accreted onto the core of Laurasia, old North America, at about 1.7 billion years. That's amazing. You want to see it? Let me flip you around. Sun's probably wrong for you, huh? Yeah, sun's wrong for you. This thing's heavy. So this is 1.7 billion year old exotic terrain material from Arizona. And there's one more thing. Mark, I really appreciate this. Mark goes on to say, and yes, a bit outside your current neighborhood, but I've never known a geologist that didn't like a pretty rock with a good story. Finally, I found this photo on the internet, and my understanding is that this was taken in the last few seconds of the game, and John Stockton had already geared up to make a dash out the back door to slam down some strike and dip measurements on possible Quinellian thrust faults. So Mark, I don't know how you found this. John Stockton watches this show on occasion, but great find. That's a Breton compass that a geologist uses. That's a hand lens. That's a rock hammer. Thank you, Mark. All right. Okay. Well, Bijou is sitting on the books right now, so I'm going to kick him out of there. Yeah, you're done. It's already 2 minutes after. I'm sorry to be late. Can I check one more time? Are we doing okay? And then I'm going to need another couple of minutes to collect my thoughts here. I'm a little bit late. To be totally honest, I had trouble with the phone. I couldn't connect. I had to totally shut down the phone and restart it. We're good? Okay, great. Thank you. We'll start in 1 minute. Are you going to stay out here with us, mister? That sun feels pretty good, huh? Hot mic. All right. Hello and welcome. It's a beautiful Friday afternoon here. The wind has temporarily calmed down and maybe it'll kick back up again, but we're sheltered here and we've got nice strong late afternoon sun. In fact, hang on, I should protect this phone so it doesn't melt again. If you were with us a couple weeks ago, the phone literally shut down because it was too hot. And that sun is strong right now. Cozy Fort by Steve a little early. Oh, I need an anchor for this blanket. I know, I'll use a banded iron formation. And where to go? All right. Thank you for your patience. Okay. Today we're talking about the San Juan Islands here in the state of Washington. Can you believe it? We're finally here. So it's essentially November, a couple days from now. And I promised that by the time we get to November, we would be in the North Cascades and we would be in northern Washington learning and applying what we had learned earlier. So most of September in this series, when we started, we were setting the table with a bunch of concepts. And then for most of October, we were up in British Columbia. I'm reminding you what we did. And we built 5 huge exotic terrains, one at a time, essentially. We had a show for each. Quinellia, Cache Creek, Stikenia, Alexander, and Rangalia. Remember? Actually, let me... So I did this in the last show. I'll show it to you again with some beautiful new clipboards that I have. Thank you, Dave. So Quinellia, Cache Creek, and Stikenia came in together as the intermontane superterrane 170 million years ago. That doesn't say that the rocks are 170. It means that they accreted or added to the edge of North America roughly 170 million years ago. And then the insular superterrane, the topic the last couple of sessions, is Rangalia and Alexander terrain joining up offshore and then being added roughly 100 million years ago. Now, I've learned a lot for today's session in the last 48 hours, essentially, and I'll say right up front, I've been surprised at the timing of today's topic. For some reason, and maybe I read it and saw a diagram and just it stuck in my head, but for some reason I thought the timing was such that the San Juan Island exotic terrains, the topic today, were caught in between these two super terrains when they finally collided together. And we are talking about thrust faults, which mean that the crust was compressed. And we are going to be looking at the exotic terrain rocks that are here in San Juan Islands. And then we've got a couple of special viewers who have some memories for us of the geology of that area and the geology workers of that area. But I got to say, I'm still trying to process what I think I understand now as far as the timing of this. Bijou has climbed up in Larry the ladder and is now poking his head out through the quilt underneath the phone. Adorable. A touch more review and then we're ready to go. So we had this format, do you recall? We had this format for learning the rocks of these exotic terrains. And this is the format we will use again today. I don't know, maybe it's the format we'll use for all the rest of the exotic terrains that we study in the North Cascades, etc. But I'm reminding you that Quinella had a variety of rocks in this age span. And we have plenty of arc volcanic material on top of older basement. Same for Stikenia. Arc volcanic sitting on top of older basement. All in the neighborhood, I hope you can read these numbers here as far as millions of years ago. This is not age of accretion, this is the age of the actual bedrock in those two exotic terrains. And then we stress the point very, very carefully, and there's a reason I'm going through this again with you right now. We stress the point pretty carefully that the Cache Creek terrain, which is sandwiched between the twins, has Tethyan fossils within it, indicating a very long journey from across the Pacific. So it's basically Asian material in the limestones and the oceanic plateau material that was probably originally off the coast of Asia in the southwest Pacific. And here it is, making up a large portion of British Columbia. Last review, piece of paper. More recently, we talked about the insular superterrane, both Alexander Terrain and Wrangellia. Now, these are not the twins. These have a totally separate story from each other. And if you recall, the Alexander Terrain, the oldest rock of the Alexander goes back into the late Precambrian and stretches all the way up to almost 260 million years ago. What was our conclusion from this Alexander Terrain story? It's the leading idea. I don't know if it's a done deal, but the leading idea for the source of the Alexander Terrain was Northern Europe, was Northern Eurasia. And bringing the Alexander Terrain, do you recall, through the Arctic, when the Arctic was at a lower latitude, but through the Arctic, and then getting offshore of Western North America. This is the most recent exotic terrain we discussed. Jerome Lessman, Vancouver Island University, gave us a field report. We're holding on to his other field report for a while. But the main message from Wrangellia was talking of a large igneous province, a huge oceanic plateau that was almost completely underwater, a little bit subaerial, but for the most part, a bunch of pillow basalts of Wrangellia. And these two guys got hooked up, we think, older than 309 million years ago, but I'm starting to wonder about that based on some of your excellent questions. But our last point is that this superterrane, the insular superterrane, was added roughly 100 million years ago. Is that the last show we did? No. The most recent show was last Sunday, and we took a break from going terrain by terrain, and we talked about exciting new work by Karin Sigloch and Mitch Mahalanik, who discovered how to take ocean slabs in the deep parts of the mantle and realized that those ocean slabs used to be offshore of North America And by working out some timing and some geometry and some math and some sinking rates and everything else, it was concluded by Karn and Mitch that the insular superterrane was a volcanic arc that was stationary. It was fixed in place out in the Pacific. And North America moved westward, and there was westward subduction of ocean floor connected to North America. And I noticed that some of you were saying, well, what does it matter? Like, the thing is added on. Like, who cares who was moving or what direction the subduction was? Well, I ask you to keep score in the next few shows, why that's important, why that is important to reconstruct whether it was westward or eastward subduction and whether the insular superterrane was moving or not. I think you'll see why that's a crucial question and a crucial answer in the coming shows. But we're finally to talking about the San Juan Islands themselves. And your friend Bijou is still hanging out in his new home, and I'm half distracted by that, but I'll try my best to focus on you. San Juan Islands. So for those that are watching from distant lands, we're in Washington, and we're probably in Washington to stay, to be honest. We're in Washington to stay. And to get to the San Juan Islands, which is truly a beautiful collection of islands out here in the water. This is northern Puget Sound. This is the Salish Sea. I'll just slow down and give you a chance to look at this. Now the colors are wrong for us, but this is the Olympic Peninsula. This is Seattle, Washington. Here are the North Cascades where we are heading in the next few sessions. My backyard is here in Ellensburg, Washington. But it's going north on a freeway called Interstate 90, about an hour and a half. You get to a ferry dock near Anacortes, Washington. That's a town. We're going to do a little geography here just to get ourselves kind of situated. And then we're going to cruise around on these islands out here in Puget Sound. And maybe you're from Washington and you go, well, wait a minute. Seriously? I thought it was nothing but glacial deposits all through Puget Lowland. And you're right that Puget Lowland deposits are almost all glacial. Whidbey Island. All those islands south of, I can't think of another one right off the top, Vashon Island, etc. Those are all glacial islands, glacial deposits, glacial till, glacial outwash, etc. And you'll see in just, well, let's do it now. There's a lot to take in here, and I've been busy with my colored pencils and a part of the box that the guys from Bakersfield sent. But the first thing I want to point out is there's a bunch of gray here, and the gray is glacial cover, glacial deposits. So even on the San Juan Islands themselves, there's a lot of glacial deposits from the Puget ice sheet, most recently just less than 20,000 years ago. So the glacial story is in the area, but the luxury is, if we look at the bedrock, which is a rarity in Puget Lowland, but if we do get a chance to see bedrock, and that's what all these colors are, you can have a heyday. You can have an absolute party. Breaking open exotic looking rocks, and they are truly exotic, and realizing that much of the bedrock of the San Juan Islands do have an exotic terrain history. And one of our goals is to try to tap in to what we've done already in British Columbia and see if there's any connection to some of that stuff in the San Juan Islands. Have we done anything yet? Yeah, we kind of have, but we're still just kind of setting the stage. So you're like, can I take a look at Mappy McMap and see what we're doing? Well, sure. But these terrains making up the San Juan Islands are tiny. They're itty bitty little baby, little cute little baby exotic terrains. And as Daryl Cowan is fond of saying, and Daryl is with us today, I think, Daryl, can you identify yourself here, Daryl? He goes by a handle of like Apenino or something? Something. So if the drinking word today is Daryl, you're going to get drunk because Daryl is featured in video. Daryl is part of the Roadside Geology authorship team. There he is. Apenino. Thank you, Daryl. So Daryl is fond of saying that these exotic terrains in the San Juan Islands are just little slivers. They're slivers of something that used to be larger. In fact, I'll give you the concept right now. These exotic terrains in the San Juan Islands are so thin and small in comparison with this show that he said, he's fond of saying, the San Juan Island terrains are like hats without their heads. We've just got the hats to look at, the exotic terrain hats. But they almost certainly were connected to heads. And the heads are maybe the major story of the history of those San Juan Island exotic terrains. So, yes, I'm still setting the table with you, but here we go. I mean, how can I get in here? Can I get over the Banded Iron Formation? Can I fight Bijou for some real estate? There we go. There's some colors. But look at how adorable. Look at how cute those teeny tiny little exotic terrains are. Potentially very important, by the way. But the scale is so different from what we had up here. Okay, that was our first main message, that there are exotic terrains to look at, but the scale is totally different. Okay, I think you got it. Well, I want to show you some of the resources I've been using to put this together, and then we'll go ahead and look at the actual rocks. So there's really two guys currently who are authorities on San Juan Island exotic terrain material. Daryl, Cowan, who's watching live today from the Mojave Desert, by the way. He just flew down yesterday. And Ned Brown, who had a long, storied career as a geology professor at Western Washington University in Bellingham, Washington. So these two papers were particularly helpful to me. So Ned, if you eventually watch this, I've never met you, Ned, but thank you for this paper that you put together with George Girls, and also this paper as well, also from 2007. The book that Consuelo from Seattle sent to me, because she was done using it, is by Ned. And so if you can get your hands on this, this is beautifully done. We'll refer to it a number of times. The photos in here, the diagrams, etc. But right up front, I'll tell you that Ned has some tectonic models that are different than Daryl's. And this is not one of those shows where everything's been figured out. In fact, are any of these shows totally figured out? Probably not. But in this case, there are significant questions that remain about the history of the exotic terrains in the San Juan Islands. Not necessarily the creation of the terrains, but the major mystery is Act 2 here. How are we bringing these terrains in? So I'm a little ahead of myself. So Ned Brown will refer to this book a fair amount. In the case of Daryl, wrote this with former student Mark Brandon, and Joe Vance, I think, preceded Daryl at the University of Washington. So this is a professional paper put out by the Geological Society of America. This is my copy that I bought when I first moved to Washington in 1992. Megan Miller was my boss at the time, and I said, do we have enough money for me to buy this? She said, of course. And it's collected dust since then. So I've used it really for the first time. So I'm going to say Daryl a lot because Daryl has a lot of work in here that we're going to use with his former students and his colleagues. And of course, many of you have this book, and it's co-written, mostly written by Marley Miller, a former student of Daryl at the University of Washington. But I'm just going to say Daryl for simplicity. First, because I want to get you absolutely blind drunk today, but also because Daryl is contributing mostly to this book. And I'll show you my favorite section here. Maybe you found it. I mean, this is a roadside geology book, but does that work with the San Juan Islands? Can you just hop in a car and start driving around and easily visit all these islands? Of course not. You need a ferry. So starting on page, actually, did we discover this before? Are the pages off? Are my pages not the same as your page? So this is what my 98 and 99 look like. Those that have their book right with them, Daryl and Marley's book, is this your 98 and 99? If not, Daryl, what kind of operation are you running there? How come we have different page numbers? But my point is, Daryl takes us on a roadside guide on the ferry. On the ferry going from Anacortes out to Friday Harbor. So let's slow down and start looking carefully at the geography as well as the exotic terrain bedrock geology of the San Juan Islands. That thing's met. So I'm just going to hold this for a second. I'm kind of blinded by the sunlight anyway, but I like good strong sun. And to me, I think I've said this before, stuff only really makes sense to me if I draw it out for myself or if I color things the way that I want to color them. So this is the geologic map from the back pocket. Are you familiar with these geologic publications? Oftentimes there's a cute little sleeve in the back and you have a little gift waiting for you. Speaking of gifts, a little gift in the back cover. And in this publication from 1988, here's the old school map. Well, I've never used it. I've never really looked carefully at it. So I broke out the colored pencils and came up with a coloring scheme. And I added other things as well. So many of our viewers are from the Pacific Northwest, and I'm sure you have personal history here, whether it was a vacation or a second home or a first home or whatever. In our case, my wife Liz, 20 years ago, taught at the middle school here in town, 6th grade science, when our kids were going through the middle school, and they had a big 6th grade science class. So they'd leave on a Thursday morning at 3:30 in the morning here. They'd load up 3 school buses worth of 6th graders, the entire 6th grade student body, all the parent chaperones, and my wife was one of the teachers. And they would drive the 3 hours or whatever to Anacortes and get over to the ferry at Anacortes. And then they'd load the school buses with all the 6th graders. What a wild scene. Onto the ferry, and the ferry would go past Decatur, Blakely Islands, around the north tip of Lopez, and then arriving at Friday Harbor, a little town there. And those 6th grade science classes, my wife was always just a total basket case after that annual trip, for good reason. She spent, 48 intense hours, or maybe more, with those 6th graders, but they would sleep on the gym floor at Friday Harbor High School and get a little experience on the San Juan Islands. So I'm sure you have personal memories as well from the San Juan Islands, but that's our story. So we'll keep coming back to this, but I think it's time to go to our stratigraphic columns to give you some main messages about the rocks on the San Juan Islands. Bedrock. Like, how many clipboards does this guy have? 11. Thanks, Dave. All right, so this is your trusty correspondent using our familiar format and summarizing. You know what I like to do. I don't like to tackle every last little morsel. So these are this is my decision to break the San Juan Island bedrock into 4 major exotic terrain chunks. Each of these an exotic terrain. Can you read the names? The Turtleback Terrain, the Dead Man Bay Terrain, the Constitution/Lopez Complex Terrain, and the Decatur Terrain. Okay. Now let's scan some of these rocks in Turtleback. Again, I'm looking backwards, but I think I can read this stuff. Arc volcanics, limestone, sure, some plutonic rock down low, some more arc volcanics. That's kind of familiar. The ages here, okay, we go early Paleozoic. Okay. All right, let's just leave that alone for a little while. I don't know if I'm super excited, you say, by this, except we have a new name for some reason. Some of you are ahead of me, I hope. Dead Man Bay terrain. Okay, pillow basalts. Some deep water chert layers. Ribbon chert, in other words. Teeny tiny silica bodies that are falling to the bottom like a huge snowstorm, a constant silica snowstorm on the bottom of the deep oceans. And some limestone with some Tethyan fossils. And we will briefly visit Lime Kiln Point. I can't remember which island that's on, but we'll look on the map. I'm sure you've got it. Let's continue. Well, these two guys are coeval. They're about the same age. That's kind of interesting. Constitution / Lopez, melange. Now, if you remember the word melange, that's a kind of a jumbled mix of different kinds of ocean rocks. And some more of this chert, this ribbon chert, this beautiful kind of attractive looking layers of hard chert with some softer stuff in between. And we'll go to Rosario Head, a favorite place of mine that I learned about by using Daryl's book. And then the Decatur Terrain, Ophiolite. Now that's the first time we've really seen that word. And a week from today, we're going to have a guest in the backyard. He's a neighbor. He'll come over for a cup of sugar and also tell us about Ophiolites and other strange rocks that are found in northern Washington. So let's save our detailed discussion of Ophiolites until next Friday, if you don't mind. But there's more chert and there's some sandstone and Fidalgo Island and a high point on Fidalgo Island called Mount Erie, part of the Decatur Terrain. Okay, are you ahead of me? You're like, what? What am I? You're moving kind of slow today, by the way. Why don't you pick up the pace? Well, no, I'm not going to. You know I work kind of at one pace. But I'm hoping that you see some familiar scenes. In fact, aren't these familiar colors? Isn't this yellow and isn't this grello? Gray combined with yellow? The answer is yes, it is. So what's the reveal? I can't read your comments, too much sun. What's the reveal? These rocks being so old and having a few distinctive marker beds within them. What does the turtleback terrain sound like? Hang on, Patrick. It's a conventional message in the literature. It's not me grasping at straws. It's pretty conventional that the turtleback terrain of the San Juan Islands is awfully familiar, not identical, but awfully familiar to the Alexander Terrain, which you recall is exposed much farther north of Vancouver Island. Let me remind you where the Alexander Terrain, yellow, is located. Alexander Terrain, Prince of Wales Island, north, the coast of BC up to the walls of Glacier Bay. I'm saying that there's a little bit of yellow in the San Juan Islands, and I chose yellow because there's enough convincing data to say that the turtleback terrain is the same stuff and therefore has the same source, the same general source, which is the northern Eurasia source. Hold on, what am I saying? Where's the turtleback terrain on this map? It's here. The northern half of Orcas Island is made out of the turtleback terrain. which is probably Alexander Terrain material. Pause for dramatic effect. This is an immigrant that came through the Arctic and is now making up the northern half of Orcas Island. And you're like, oh, so everything here then is from Europe? Nope. Just the yellow, just the turtleback terrain, which is not only the Turtleback Creek, but the what's called East Sound Group. That's Ned's terminology. These two guys together, Alexander. Oh crap, so much for the reveal. You can read, right? So if I mention that next group I'm reminding you now what Grello was before, with Tethyan fossils. Grello that has a long story, a long travel story, a trans-Pacific story. Yes, also not controversial. Most workers now see that because there are Tethyan fossils in the Dead Man Bay terrain of the San Juan Islands, the Dead Man Bay terrain came from across the Pacific, not through the Arctic. But today, they're sitting side by side. How's the viewing here? My goodness. I'm totally blind, but I'm assuming you can see this. So here's the gray mixed with yellow, coming through this little sliver here. We'll talk about the orange in just a second. We're just looking at the bedrock and how we have Dead Man Bay, which is the Orcas Chert combined with some volcanics of the Dead Man Bay volcanics. It's really those Tethyan fossils that tell us we can correlate pretty safely this Dead Man Bay terrain making up the central part of Orcas Island, making up the northern part of the big island of San Juan Island, Trans-Pacific. So that's why I chose yellow and Grello, same colors we had before. Now I had hopes of taking the other two guys and doing the same kind of correlation. Bijou Baxing on top of all the maps. If he wasn't so darn cute, I'd shoot him away with a BB gun. Whoops, sorry. I have just kind of a philosophical question for us. And I don't have an answer. But my philosophical question is, I don't know if it's philosophical, but my big question is, that's kind of a work in progress, is, are things as obvious as they appear to be? Like, I haven't been up in BC hardly at all, you know that. So I don't have personal stories of going here and here and here and seeing all this stuff. Is it as simple and as big and as massive and as kind of clearly laid out as it appears in all these reports in British Columbia? And, play along with me, are many workers pretty confident that we have Cache Creek and Quinella in the Blues, and Cache Creek and Quinella in Northern California, and Cache Creek and the Quinella in the Sierra foothills? Are we confident of that too? If yes, then why aren't we finding a whole bunch of Stikenia, Cache Creek, and Quinella, like obviously where we are now in northern Washington? And you're like, well, I think you just did it, didn't you? Well, yeah, in the case of the Dead Man Bay terrain, apparently, pretty sure it's Cache Creek. But as we'll see, once we get into North Cascades, and maybe I'll make some connections and connect some dots that don't seem to be obvious to people. But Daryl in particular, who's been emailing me and very, very helpful, he says that once you get into North Cascades, I don't think you can do it. I don't think you can find a bunch of Quinella and Stikenia necessarily. And a bunch of people have tried. A bunch of field geologists have tried. Nobody can agree. So I thought possibly that was a doable thing for us. I don't think it is, based on what Daryl has to say. And so I went into that little, it wasn't a rant, but that little improv, because what do we do with the green and the purple? These are new colors for us. I hereby declare. I hereby declare. Get off the clipboards, bro. I hereby declare that the Constitution/Lopez terrain is green. And I hereby declare that the Decatur terrain is purple. Now, are we going to do more green and purple on Sunday? Maybe. Is there going to be a ton more green and purple? In other words, matches or extensions of these two guys, which are only in the San Juan Islands for us today, but are we going to find more of them, I don't know, hell, all up and down the west coast of North America? Maybe. I'm not being coy. I don't know. But from a teaching point of view, I want to go there, of course. I want to tell a bigger story. And Andy Miner in Cle Elum, who's my biggest, longest pen pal on this stuff, is constantly saying, don't do it. You can't do it. Don't dumb it down. Don't make connections that aren't there. I know you want to. Don't do it. So I'm listening to my advisors. So let me show you a couple of these picture books, and I'll show you a little bit of the Tethyan fossil limestone, which has been converted to marble in some places, the Rosario Head on Fidalgo Island, Mount Erie, and other places on this. Actually, before I show you those pictures, let me finish the work on the map then. Hope we're doing okay. Again, we're ignoring the orange. Those are thrust faults. Let's ignore them right now. So all this green, there's kind of two shades of green. There's kind of the Constitution Formation and the Lopez Structural Creek Complex. Daryl lumped those together in his book, so we'll do that here too. And again, I don't have a correlation. We might eventually, but I don't have a correlation for you now. But you can see that a substantial part of San Juan Island itself, including Friday Harbor, is our Constitution/Lopez. We come through Orcas, and we even swing down here, this little sliver of Lopez Island, and this little sliver, oh, still on Lopez, and even a little bit down here at Rosario Head is our Constitution/Lopez. Now remember, these guys are pretty much the same age. I forget, like 160 to 100, I don't have the numbers, I should have wrote them down. And just to finish, our purple, hope you can read this, is the Decatur Terrain, which is a combination of the Lummi Formation and the Fidalgo Complex. So that's where we have our Ophiolite and our diorite, our big plutonic rock, and some other complicated rocks that are part of a story there. I can't hold it. You're going to have to wait. I got to find this. Again, I'm trying to give you conventional interpretations. I'm going to show you a PBS episode that features Daryl, and the topic is wrong, actually. The topic is Baja, BC, and we're not going to deal with Baja, BC till a month from now. But I want to show it to you today anyway, because we filmed it at San Juan Islands. We got Daryl up on this beautiful Mount Erie location. It almost looks like a green screen. It looks too perfect to be real, but I assure you it was real. And Daryl was so good on camera that we used way more of him than we normally do in those little short episodes. But this is from when I was putting that kind of show together, and I was trying to visualize what the Decatur Terrain was really trying to represent. and this isn't colored or everything, but we have our Ophiolite sequence that comes next Friday, our diorite of Mount Erie, our limestone coral reefs, our sandstones, our volcanic material. All of these rocks are found in the purple. And for my purposes, where I'm trying to communicate with a general audience, the main message is this Decatur terrain is representing some kind of volcanic arc, some sort of oceanic, oceanic volcanic arc that looks like this, with a subduction zone nearby, maybe westward subducted, maybe eastward subducted, maybe northward subducted, I don't know. You know what my gut says. Is the Decatur Terrain Stickinia? Is it Quinelli? Is it one of the twins? If it is, how would we decide? What kind of clues would we have in all this purple of Fidalgo Island, Decatur, Lopez, Blakely, Cypress, Guemes, if that's how you say it, Lummi? Is there a way to correlate? And is it important to correlate at this point? As we'll see with these thrust faults, it's a hot mess. And it's difficult to visualize the sequence of bringing things in. We haven't accreted anything yet. I'm just talking about the geologic history of building each of these exotic terrains. Okay, give me a second. Let me see if I'm done with Act 1. That was a long act. The other acts are short. Yep. Right. No, I'm not even going to show that to you. All right. Hot mic. Oh yeah, I wanted to show you a couple of books. Oh, there's even another book I forgot I had that I want to show you. So some of you may know Gene Kiver, K-I-V-E-R. He was a long-time geology professor at Eastern Washington University in Cheney, over by Spokane. And I know Gene a fair amount, and I know that he splits time between Anacortes, half the year, and Cheney, over by Spokane, the other half. It seems like a great setup. And Gene has put out a lot of publications, not only in the scientific literature. He's all over Ice Age flood stuff, for instance. He's the co-author with Bruce Bjornstad on the Trail of the Ice Age Floods, Book 2. But Gene also has done, I don't know if he's done more than one of these, but this is him and Chad Pritchard at Eastern Washington, and I don't know Richard. But here's another book for your library if you're interested. And Gene and Chad are going all across the state, and just kind of, it's almost like a coffee table type book. There's some beautiful photos. But he picks, Gene does, because he lives so close, little places to visit in the book. Limekill Point, Iceberg Point, Washington Park, that's on Fidalgo Island, a really wonderful place, and Deception Pass. If you're waiting for it, Deception Pass is part of this story. So let me do this quickly. Let me do this quickly. The hell is it? Sorry, Patrick. All right. So Limekiln Point, it's a bunch of limestones with Tethys fossils in it. So that must be Dead Man Bay terrain, right? That must be Cache Creek that crossed the ocean. Why is Washington's Park so cool? Well, I'll just give you a little bit about an ophiolite. An ophiolite is looking at the subflooring of an ocean floor, like it's mantle material. It's a rare chance to look at mantle rocks that somehow are out of an ocean setting and crammed onto a continent. And Washington Park is unique for a number of reasons. It's very close to the ferry terminal at Anacortes. There's this cool little drive, there's kind of a slow little road going through this area, and you're going through all this very crazy looking mantle rock and serpentinite and other things we'll learn more about next Friday. But Washington Park, a special place on Fidalgo Island. And then, yes, some of you know about Deception Pass, which is a beautiful area, very, very popular Washington State Park at Deception Pass. The actual body of water, Deception Pass, has this majestic bridge, but the bridge is anchored on both sides with exotic terrain material. I guess it's Decatur Terrain, although there might be a little bit of Lopez there. Okay, so Washington Rocks by Gene Keever. Let's do more of this little photo trip with Ned Brown's book. Wind isn't too bad. I'm happy with the protection here. So the Alexander Terrain, aka the Turtleback in the San Juans, Ned Brown, from all of his multiple decades of work, gives us some looks at these rocks that used to be part of Europe, according to the leading idea, the Turtleback Terrain. Just giving you a little sampler for what it's like to be looking at rocks. I mean, you're not by the side of the road here. You're not by some off-ramp, in Tukwila. I mean, you're in beautiful terrain. And I mean AIN, beautiful terrain that exposes terranes, ANE. Look at this ribbon chert. Ocean, most of this has an ocean story, of course. All right, pick up the pace, pick up the pace. I want to find a cartoon that I like. There's a couple that I like while I'm in Ned's book. Wrong colors for us, but another shot at the main story. I promise I'm getting to the thrust faults, but I'm having a good time here. Give me 10 more seconds. If I don't find it, I'm quitting. Here. We tried to do this in the Cache Creek show. Do you remember? We had a picture that looked exactly like this, and I said, if you can imagine this Cache Creek material with the Tethyan fossils are depositing in an ocean basin offshore of Asia, and then obviously there's a different global geography during this time. And then this material, this is today's Dead Man Bay terrain, right? Is arriving on the other side of the world. God, that's amazing. That really is amazing. And now that I'm giving all these other books a shine, and since Daryl is watching, of course we have to work with these pages and just do a little bit more, although I'm assuming many of you have this. So here's just Fidalgo. So I copied Daryl and Marley with their purple for Decatur and their green for Lopez/Constitution. And I love Rosario Head. If you only have one place to go that you can just drive to, you don't have to get on the ferry for this. I mean, Washington Park's pretty sweet, but I love Rosario Head. And there's actually two terrains there. There's the Lopez with the stunning ribbon chert. There's a little bit in the video I'm going to show you. And then the Decatur as well. Which terrains are those connected to? Slide Mountain Ocean? Franciscan in California? Quinelius, Tequila? I'll stop. And just to be complete, wrong colors for us, there's Daryl and Marley giving us our ferry ride and the same general story. Okay, I think by now you have different sources, different ways to present the terrains, A&E, of the San Juans. And the main message is we have 4 exotic terrains in the San Juan Islands with 4 completely different stories. In the case of two of them, from different sides of the world. They're coming through the Arctic and across the Pacific, and here they are in the San Juan Islands. We're transitioning now, and this will be quick, to the thrust faults, and it'll be quick because there's major questions. But we do know a couple of things. So, I'm going to use a combination of Daryl's map and Ned's cross-section. So let's go to this map. I hope this is helpful to you. It was helpful to me, again, just to get this stuff down in one place. So now that we're comfortable with places and island names, and yes, there's something called the Nanaimo group that's up here that I'm not focusing on today, but this will come up just a little bit today. But now I would like to look at the boundary between these exotic terrains. So we have 4 terrains and we have 3 orange faults. So of course, if these are completely different stories coming from different parts of the world, there has to be a very abrupt fault boundary between those exotic terrains, and that's definitely the case. And by detailed work on these 3 orange faults, we know that they are thrust faults. Thrust faults. You're like, I don't think I know what that is. Well, first message, different kinds of faults tell us about different actions with the crust. If you are a normal fault, that's a fault that's making earthquakes, and a normal fault is the result of pulling the crust apart. Crustal extension, you make a normal fault. Is it a strike-slip fault? And we'll be getting back into strike-slip faults in the next couple episodes. Strike-slip fault, okay, that's a different kind of fault. We're making earthquakes on a strike-slip fault. That means the crust is being wrenched laterally. Reverse fault, that's something different. A reverse fault is correct, making earthquakes, but a reverse fault is from squeezing the crust together. I'm going to draw this now. So, those are 3 words that I think you know. Thrust, reverse. No. 3 words I think you know. Reverse, normal, and strike-slip. You know 3 words, normal, reverse, and strike-slip. But today we're talking about thrust faults. So what is the difference between a reverse fault and a thrust fault? And is it important to recognize that there's a difference between a reverse and a thrust fault? This goes back to the spring when we had different live streams, and I did one on faults, I think. I can't even remember. So we have a hanging wall and a footwall. We have an angled fault. This is a cross-section. And we have a fault going into the earth at an angle. In this case, it's a pretty high angle. It's not a vertical. It's not a 90-degree angle, but it's not a very low angle, almost flat fault either. It's got an angle that's, let's say it's got a, this fault has an angle away from horizontal that's steeper than 45 degrees, okay? A high angle fault, a steep fault. And if we have an earthquake and the hanging wall abruptly lifts compared to the footwall, we call that a reverse fault. And a reverse fault is the result of crustal squeezing. You squeeze the crust. If you make a high angle fault and the hanging wall goes up, you're going to make earthquakes. The Seattle fault, for instance, totally different from today's topic, but the Seattle fault is a high angle reverse fault. Okay, well, we have thrust faults today. Those 3 orange lines on that map are thrust faults. How is that different? It's very similar, but a thrust fault is a low angle fault, not a high angle fault. So this was a fault that was steeper than 45 degrees. Here's our 45 degrees away from horizontal again, but now, what if our fault is in this sector? What if our fault is lower than 45 degrees? I'm not talking about temperature, right? This is a little bit of geometry. So let's say this is a 25-degree fault. It's not zero, zero is flat, but it's 25 degrees, a crack going into the earth. But we still have a hanging wall, we still have a footwall, we still have crustal compression. And when we have an earthquake on a thrust fault, we still have the hanging wall going up. To review, both reverse and thrust faults, oh gosh, oh that's right. Reverse and thrust faults are both the result of crustal squeezing, crustal compression, shortening the crust, causing uplift, by the way. If we have these hanging walls go up, we're going to have some uplift. We're going to build the crust up. We're going to intensify the erosion on that uplifted block, on that hanging wall block. This is what we want to visualize for the San Juan Islands. Now that we know we have thrust faults with a low angle versus reverse faults with a steep angle. Anybody still with me? I have a prop. What props could I use from the kitchen to show that these are thrust faults and that these pretty thin, teeny-weeny, baby little exotic terrains are thrust sheets, also called naps, N-A-P-P-E, if you want to really impress your friends tomorrow morning at coffee with your masks on. You guys know what a nap is? N-A-P-P-E? I do. It's a thin sheet of bedrock that gets shoved up a thrust fault. So, anyway, what were we talking about? So each of these is a thrust fault, and the black teeth, if you can see the black teeth, show us that the hanging wall is on this southeast side of each thrust fault. So I want to generalize before I show you my prop. I want to generalize. I know these are curvy, but I want to generalize that these three thrust faults have a trend northeast-southwest. Are you willing to do that with me? I just erased it, but I want to do it again. Top of the hour. Top of the hour. I was almost sure this was going to be a shorter show. What a laugh. As Merle says, what a joke. On a map of the San Juan Islands are three thrust faults, north, south, east, west. That's the thrust fault. This is the thrust fault. We got three of them separating our four terrains. I'm hitting hard what we know because we don't know much more than this about the thrusts. I'm talking about Daryl and Ned and all their students and anybody else who's worked in this area, as far as I can tell. Okay, northeast, southwest trending thrust faults, and I'm saying what? The thrust faults mean we have compression. So, from which two map directions are we going to be squeezing if we have northeast, southwest thrust faults on a map? I'll wait. From which two map directions, I don't know if they're cardinal directions, from which two directions are we going to have squeezing? Pat Miller, northwest, southeast, southeast, northwest, Yeah, way to razzle dazzle there, Scott. Correct. Now it's tempting to hit that pretty hard and go, hey man, you know, when these terranes came in, we had a northwest-southeast collision. But you know how crazy the paleogeography is. And we're back a long time ago, so who knows what the orientation of these things were when they were active. But that brings up a question. When were these thrust faults active, and what is the frickin' prop? I'm tired of waiting. Let's do the prop first. This episode of Nick from Home brought to you by California Pizza Kitchen. You gotta love it. We like the crust. And when we're particularly burnt out and don't feel like cooking, we pop in a California Pizza Kitchen. So check it out. It's a frozen pizza. Check it out. It's pretty thin. This is a nap. N-A-P-P-E. It's only a nap if it's a thrust sheet that has been thrust over another thrust sheet. So what you want to do is you want to take a 4-cheese California pizza. That's one exotic terrain. You got another totally different kind of flavor. A white. Ready? Compress. 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 That's nap action, baby. That's 2 exotic terrains. Totally different pizza, different flavor. Came from another part of the world, like Italy. I don't know. Stupid. Thrust sheet. Nap it up. Earthquake each time. We're going up. We got another one? Oh yeah. Margarita. Okay? 4 exotic terrains making up the bedrock of the San Juan Islands. 4 very clear naps in a thrust stack. I can't hold it. I'm going to give it to you verbally. I'm not going to write it down. You ready? Do you remember at the beginning of the show I was surprised at the age of action on the thrust faults? I thought everything was getting caught between Wrangellia and the Insular with Intermontane. Not so. Here it is verbally. The stacking, the thrusting, the uplift happened between 100 and 84 million years ago. What am I talking about? I'm not talking about the age of the rock now, right? I'm talking about when were these sheets active. They came from 4 corners of the world, let's say, but here they are together and they're being thrust one on top of another. And they were doing their thrusting, they were doing their earthquake activity up those fault planes in a very specific time window between 100 and 84. And you're like, 100, that sounds familiar. 100, what was 100 again? That's when insular superterrane came in. That's when Wrangellia came into this area. So this thrusting happened in the San Juan Islands after the insular superterrane arrived. I don't get it. Thrust sheets? Now, I did a quick email last night because I was confused, and Daryl replied. I said, Daryl, do we know the relative age of these blocks? I mean, like the emplacement age of this? Like I'm showing you, just lost a terrain. I'm showing you that the bottom guy was here first. This is easiest for me to visualize. The turtleback was here first. Here comes the dead man, dunk, 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 getting shoved up the ramp. Then the Lopez Constitution, then the Fidalgo. Daryl says we don't know that. We don't know that. To me, this is like a 4-car pileup. You know, each car's coming in and being shoved up the back of the next one, like a retarded game of leapfrog. Sorry, Patrick. But there's no evidence to prove that timing. But I don't know if it matters. We have compression, we have thrusting, and we have uplift, and I can't hold it. God, it's almost 10 after. It's fun. I'm sorry. I can't keep these under an hour. There's no way. This will be quick. Famous last words. But the idea is that when we do our thrust activity, our hanging wall gets shoved up. I've already mentioned that there's some uplift then. We're actually creating some ridges or maybe even some mountains in what is now the San Juan Islands. And there's a general law in geology that uplift intensifies erosion, just generally, cartoonishly. If you do a lot of uplift of an area, you're going to energize the rivers and the glaciers and other things to kind of chew away the topmost part. It's almost like a circular fan, like a ceiling fan, but let's pretend that ceiling fan is a circular saw, okay? And let's have our pizza boxes, our thrust sheets, our naps. Let's keep sending those pizza boxes up their thrust faults until they intersect with the ceiling fan. What's the ceiling fan, the circular fan? It's rivers. It's erosive agents on the surface. So we're sending our pizza boxes up into the ceiling fan, and we're going to chew off. We're going to keep chewing off the leading edge of the pizza box. We're going to erode and crumble. We're going to make sawdust out of these sheets of plywood that we're sending up in the circular fan. Can you keep track of all these analogies? And the sawdust that's coming off of this erupted, sorry Patrick, the sawdust that's going to come up away from this uplifted hanging wall is a pile of sedimentary rock nearby. It's called the Nanaimo group. We're not going to talk about the Nanaimo group today. It's got a whole separate story. But most of the work that I've been able to read, and maybe I'll get some help from some of you, but the sediments called the Nanaimo group are a direct result of eroding the uplifted naps in places like the San Juans. And if you're waiting for details on where these 4 terrains are coming in, when they're coming in, how they're getting parked, we don't have it. So we are embracing together major stories of exotic origin of these 4 terrains, and now that we understand that these orange things are the thrust faults that separate the pizza boxes, that's going to have to be good enough for us today. Act 3 are a couple of quick memories. Not from Merle. Merle Beck has been writing up some wonderful little personal memories for us about the early days of exotic terrain research. I have one memory from Pat Miller, who I just saw was with us. Does that name sound familiar to you? Pat Miller? Pat Miller. Pat Miller created this out of wood. And there's a personal story that I shared last spring about rock columns that I was walking around on, and then I dropped one of my rock hammers down a crack between two of the columns. And so Pat took that and, as an artist, created this out of wood. Including the rock hammer. I shared this last spring, but I don't want to say it's a favorite gift because I love all the gifts, but pretty good gift, Pat. So, Pat Miller. So Pat emailed me this week and said, you can share some of this if you like, maybe just for laughs. Pat was a geology major at Washington State University in Pullman, and they did their summer field class, 7 weeks of it, in the San Juan Islands in the summer of 1971. Nick, I did my Washington State BS in Geology field camp requirement, spending 7 weeks in the San Juan Islands in the summer of 1971 with 7 other guys under the direction of Dr. Frank Scott. My 50-year-old report is attached here. I thought you might enjoy a bit of very old and Bush League reporting. He was like a senior as an undergraduate. Maybe just share it for comedic relief. So I printed out one of his pages. I won't embarrass you too much, Pat. It was kind of fun to read. This is Chapter 5, Historical Geology, from Pat's report in 1971. The geologic history of the project area is best explained on the regional scale with particular attention paid to those events pertinent to the area. These 3 general statements can be made about the history of the region. You're stalling, Pat. These are that the area has always been in close contact with the sea, subject to much volcanism, and in a highly active area of the crust. And he goes on from there. To be fair, barely knew about plate tectonics in 1971, so I think you're off the hook. The other memory is from Daryl. Daryl wrote this up, it's online, called The Geology of the San Juan Islands by Daryl Cowan. I'll just read you a portion of it because we're running late. Daryl Cowan from the University of Washington, he wrote this recently. I'd like to describe a role that Roy McClellan and other faculty members and students at the Geology at University of Washington have played in investigating the very challenging but intriguing bedrock that lies beneath the extensive veneer of softer, more easily erodible glacial deposits. McClellan made his map as part of a PhD thesis, which was the first in geology at the UW, published in 1927. McClellan defined several new formation, rock units that consist of distinctive rock types. Someone told me that he studied the extensive coastlines by rowboat. I think his work in the field and in his thesis deserves to be called monumental. Decades later, Ted Danner in the 1950s made an exhaustive study of rock units in northwestern Washington, and that was his PhD thesis, completed in 1957. Ted Danner. He probably visited even the most remote outcrops and quarries. In the San Juans, limestone was economically important, and perhaps Danner's most important discovery was the remarkable similarity of fossil fusulinids, marine foraminifera, that lived in the Permian to the same protozoans found in rocks of the same age in Japan. Those are the Tethyan fossils we're talking about. So that was discovered in the 1950s by Ted Danner at the University of Washington. Danner later became a professor of UBC, British Columbia. In the 1960s, UW professor Joe Vance began geology mapping and studies of the bedrock on Orcas and San Juan Islands. And then Daryl writes, I arrived in 1974, and I visited UW professor John Witten's field class for majors and non-majors at Camp Norwester, and then on Sperry Peninsula on Lopez Island. And Daryl reports that the 1927 to 1975 maps held up pretty well. Wetton kindly showed me other outcrops on the islands, and in 1976 I began a multi-year study of the bedrock of the archipelago. We stayed in dorms at the labs, Friday Harbor Labs, which I must say were pretty rustic compared to the relative luxury of the accommodations today. What had changed from the pioneering work of McClellan and Danner? Plate tectonics. We are now comfortable with the idea of mobility of the Earth's crust. Rocks can move. The complex rock units of the San Juan Islands were assembled into a collage about 100 million years ago. A key debate still remains centering where this collage originated. Okay, thank you, Daryl. Thank you, Pat. We're going in the cozy fort. I don't know if Bijou's still with us or not. No, he took off. Almost 800. Good. I've got some video clips to share with you. Cozy Fort by Steve. Trademark. Some of you were not with us in spring, and you're like, what's up with, why do you call it the Cozy Fort? It's a long story, and I shared with everybody in the spring, but my dad was a good dad. And when we were kids, my sisters and I, whoa, I'm going to need that band and iron formation again there, Mark. My sisters and I would make forts out of cardboard boxes in the basement, and we called it Cozy Fort. Maybe you did too. And my dad was an old football player, big guy, but he would crawl in there with us, and we would have little parties. And so, Cozy Fort. No crying in the Cozy Fort now. Too late. All right. So I'm muting the live us. I'm muting us. I got a few things to share with you. Now, to start with, I mentioned to you that Puget Lowland is mostly islands made out of glacial deposits. And many of them are drumlins. And look who spent some time with Randall Carlson on his YouTube channel, Jerome Lessman. And this is a 2-hour program. I'll show it to you again. You go to the Randall Carlson website, Randall Carlson YouTube channel, and there's the title, episode 47, Drumlins. And there's a whole team of people, including Randall Carlson. If you don't know who that is, Google him. And Randall kept his mouth shut, and Jerome went nuts for about 2 hours.
The best piece of evidence you have for abrasion by a glacier. In other words, if you think of a glacier, the base of a glacier that's charged with all kinds of pieces of rock and other sediment, as a great big piece of sandpaper.
So you want a heavy dose of Jerome.
It's going to
he did a great job. Jerome, you did a great job with that. And I hope you're invited back. There was talk of you coming back. So we're not talking about glacial stuff today, but that was, I think, worth it. Just in case you don't know the Pat Miller story I was telling you about. '12 on my 50th birthday.
Top of a column, top of a column, top of a column. Hello. Beautiful show. Oh, shit.
Sorry, Patrick.
We'll be back with a big magnet.
Yes, the hammer's still down there, but Pat Miller was inspired to create that piece of art, and I will have that for the rest of my days, Pat. Thank you. This is a Daryl show, so I want to show you some of the scenics created by Chris Smart, who I made these programs with. And we're going to talk about Mexico. And it's not our topic today. We will be coming back to the San Juans in December when talking about Baja, BC. But consider this a way to meet Daryl, a way to get some nice scenics of the San Juan Islands, and also a little teaser to what's to come a month from now in our series.
Discover the energy that drives a planet and builds mountains. Uncover buried treasure and see what makes mountains blow. Find out what shapes the top of the earth and explore the secret world below. With me, Nick, on the rocks.
Deception Pass.
The bridge at Deception Pass. The views are incredible. You can see all the way to Mexico, but only if you look down at the extraordinary bedrock below the bridge. Bedrock that formed in a deep ocean, then was added to Mexico, and then made the long journey to northern Washington. Look at this stuff. Kind of looks like ribbon candy, doesn't it? It's rock, up to 160 million years old. This stuff is from the deep ocean floor from the age of the dinosaurs.
That's Lopez/Constitution.
These chert layers are made of silica-rich skeletons of tiny single-celled organisms called radiolaria. They float for about a month in the ocean before they start sinking. Like diamonds deep in the earth, the silica skeletons face incredible pressure from the thousands of feet of water overhead. As a result, the tiny skeletons are transformed into chert bands.
Drone shot.
Silica-rich rocks that tell a deep ocean story. Is it possible that these rocks were accreted in Mexico
Mount Erie.
and then sent north almost 2,000 miles?
Here's Daryl.
Up until pretty recently, we basically had paleomagnetic data. There weren't good geologic arguments for where these rocks were, and secondly, how do you get them up 3,000 kilometers along the coast? But now, just in the past several years, detrital zircon work, where workers from University of Calgary and elsewhere have analyzed samples of the Nanaimo group, which is part of the San Juan Islands.
That'll come later.
Found that the detrital zircons very likely were eroded from granitic rocks at the latitude of Los Angeles, the Mojave Desert. And so I think now this has caused a resurrection and interest in the Baja BC hypothesis, because it is a completely different line of evidence that you could use to argue in support.
And the evidence comes in all shapes and sizes. Exotic-looking bedrock like this all up and down the west coast of North America. Granitic mountains with a tropical paleomagnetic signature, all the way down to little single grains of zircon minerals that are new kinds of evidence that tell us that rivers long ago in Mexico traveled over bedrock like this. It's now clear to many geologists that everything in western Washington that's older than 50 million years ago was part of this Baja BC movement. Anything younger than 50 million, the Cascades, the lavas of eastern Washington, the Ice Age floods, that's homegrown. Deep ocean rocks that not only made it to dry land, but also got sent packing almost halfway to the North Pole, are just another reason to enjoy Deception Pass State Park.
So that's the work of Chris Smart, who works here at Central Washington University. And I don't know when we're going to film more of those. We couldn't this year. I think that's enough. I had a couple of our animations from the last couple of shows queued up, but we've already seen those, and we'll come back and visit those again. But it's almost 3:30. It's time for some Q&A, and we can get rid of this couple of jokers we have with us, hopefully. It's time for some Q&A. Thank you for still being with us. Woo! If you're new to us, we do Q&A with uppercase. You caps lock. And I try to answer a few questions. Boy, that sun is... I'm going to move this a little bit. We'll try a little bit of this. And then we'll have a little happy hour here. I'm popping the chat out like a boss right between the eyes. I'm not a top chat guy. I'm a live chat, although I don't know what the difference is. Scrolling back, we'll try to do a few. Oh, we got trolls. We're just ignoring the trolls. Okay. Hopefully we're focusing on what we're doing here. What's the difference between a footwall and a hanging wall? They're just labels for two blocks of crust, either above or below the fault. So if the fault has an angle like this, underground, then there's a block of crust above the fault and a block of crust that's below the fault. Hanging wall, footwall. They're just labels for the blocks so that when those blocks start moving, we can describe the block motion. George, how thick and how long are the slices of terranes, and can you estimate how thick they started out? Great question, George, from Iowa. Daryl told me in an email, and I forgot to look that up. Less than a mile thick, let's say that. Oh, is that right? Hang on. By the way, as I'm looking for this email from Daryl, some of you have mentioned that you have a hard time joining us live because you can't find the live thing on my YouTube channel. I have a tip for you. I think YouTube recently changed it. I don't think I'm doing anything differently. But if you're frustrated finding the live link for an upcoming show, go to my YouTube channel. It says home and then videos and then playlists. If you click on playlists, you'll find the Nick from Home playlists. And if you're in that playlist lineup, you'll see that live link. I think that's right. It's maybe not worth looking for you, George, but I'm going to give it 2 more seconds here of looking. Nope, can't find it. Okay. I've got the info, but I forgot to write it down. Sorry. Kyle, why am I wearing shoes? It's almost November, Kyle. Moto Mining, can you see the organisms in the chert without insane equipment? Probably not, but I'm not an expert there. I don't know how they isolate those super tiny forams and fusulinids. Is that the same thing? I don't even know the biology of it. But I think you need some pretty fancy equipment to see that stuff. Automatic scroll. God, there was a good one there too. Hang on. Yeah, Eric. So the San Juan Islands are basically an exotic terrain smorgasbord? Yeah, good way to say it. Sandy, don't you have wonderful drawings of the SJI naps by Elizabeth Orr? I guess I don't, Sandy. That's Elizabeth and Bill Orr. I didn't think to look in that book. Sorry. Toughen up. Are there any clips with the naps? I think so, but I kind of forget what a clip is. Is that a window? There'll be some windows in the show next time. Which way do those faults dip? They dip to the, what did we decide? They dip to the southeast. Did we relate Cache Creek to one of the San Juan terrains? Yes, we did. We related Cache Creek to Dead Man Bay. Peter, you have mentioned Northwest North America traces bumps with Europe a few times. Do you know rough ages of when? I can only find traces of crunches with South or East U.S. Peter, when I talk about Europe, I mean that parts of Europe bedrock were sliced away and sent our way. I don't think I mean the opposite, that we crunched with Northern Europe. If I get your question correctly, I'm trying to say, and we'll have this again in the next show, pieces of Northern Europe that left like an immigrant and arrived here. Like an immigrant and arrived here as an immigrant. I always screw those up. Papagino, are the San Juans part of the clockwise rotation? There is some clockwise rotation today on some of those GPS stations in the San Juans, yes. But we're talking about thrusting between 100 and 84 million years ago. And I failed to mention it then, but I'll mention it now. There's some metamorphic activity as well. As we thicken the crust, we create metamorphic rocks. And as I understand it, getting the ages on that metamorphic event, getting ages on those metamorphic events helps us constrain when the thrust faults were active. David, do you get thrust faults when continents collide? Yes, but I don't know. I don't think there's no evidence, is there, that we had another continent here? And again, the timing is we're doing the compression with the San Juan terranes beginning after the insular arrives. I guess it still could be. I need to keep thinking about that. Maybe it is driven by the insular. The insular is not just going to kiss the shore, it's going to continue to, well, remember, from Karn and Mitch's show, the insular is hanging out, fixed, and we're plowing into the insular. But is it really a 16 million year time of continuing to have the insular fight with the western edge of North America? And again, is it worth thinking about if we realize that there's a Mexico story? If you're trying to do the math on that, it's too much for us today. It's just too much for us today. Opiki, would the thrust faults operate at the same time or in sequence in time? We don't know. Yeah, that's what I emailed Daryl last night about. I don't think we have any kind of timing about all 4 thrust faults active at the same time, one at a time. If so, is it the thrust fault at the lowest part of the stack that was active before the youngest part? According to Daryl, we don't have that. And I believe him. Eric, I just tried to answer that with metamorphic rocks. I know of no, thank you, Stephen. I know of no stitching plutons in the San Juans that help us with the accretion date. There are some plutons in Fidalgo Island, let's say, but as I understand it, those are when the island arc was active offshore. Judas, why do some geologists think the same San Juan terranes won't be found in northern Washington? Well, next time, Judas, we're crossing I-5 and we're going to go into the foothills of the Cascades. Spoiler alert, we're going to find some of the same stuff. So I'm not sure who you're talking about that doesn't think there's a continuation. If you meant just my comment about how much is Stechenia, Quinelli, etc., that's a longer answer, and I don't know how to answer it right now. A couple more and we'll quit. William, were the thrust faults in the islands the result of okay. No, the timing is wrong. There's no evidence of clockwise rotation. Thank you for the question. No evidence of clockwise rotation before 50 million years ago. I think that's a safe statement. I mean, I was just teaching the clockwise rotation this morning again. I don't care who's in the audience. They love the idea of a clockwise rotation. It's just one of those that just grabs people. But we can't apply it here. There's no evidence for any sort of clockwise rotation because the plate configuration, I mean, we're talking about 100 million years ago, not 50. 50, we're recent enough that we kind of have a sense of which ocean plates were where. 100, as you saw last show, we still don't have that sense. Okay, now we're into, okay. So, a toast to you. And a thank you to you for joining us and being with us so late. What was it, Day of the Dead or something? Day of the Dead cake? He's going to drop it, ladies and gentlemen. Hang on. Hang on, Patrick. Special shout out to the clowns who are with us. Love to have you back. And I only ask one thing, that you give us your heart and you give us your mind. I see you. I know that you're here. I see you. I'd love to have you come back and we can learn together. How about that? I see you and I love you. Here's to your health. How does this stuff get shipped halfway across the country and taste like it was just made in your kitchen? We are living in an amazing time. Here's to the health of your friends, your parents, your children, and everyone in your community. With an open heart, everybody's invited. This is an inclusive place. This episode of Nick from Home brought to you by Cupcake, Cabernet Sauvignon. Yep, stealing it from my wife again. I got to run to Super One grocery store before she gets home from school. This episode of Nick from Home brought to you by Super One grocery store. Unlimited supply of Cupcake wine. Here's to you. Delightful. Next time, will be session N as we work through the alphabet together. And we will be leaving the San Juan Islands, crossing Interstate 5, and getting up into the foothills of the Cascades. Looking at exotic terrain bedrock and basically asking, can we find some of our 4 San Juan Island exotic terrains on the east side of I-5? And as we go up towards Mount Baker, Glacier Peak, etc., that's next time. Thank you for joining us today. Hope you enjoyed this one on the San Juan Islands. I love you, and goodbye. Goodbye.